Again, this has happened. Students take all this and they jam it all in there. No. We're evaluating this at the point, right? At t equal to 0. What's r prime of 0? E to the 0 is 1. 0 plus 1 is 1. And what's 0 plus e to the 0? I got 1, 1, 1. You get the same? There it is. There it is. Parametric equation alone? Cool. Hey, the next thing we're going to talk about is speed. What is speed? I know people know from calculus. I mean from physics.
Same as velocity but scalar.
Speed is the magnitude of the velocity vector. Alright? Speed is the magnitude of the velocity vector. Oh. So speed is not a vector. Speed is a scalar. Right? I was traveling 55 miles per hour speed. Right? That's a scalar number, 55. So speed is the magnitude of the velocity vector. So try this. This is the position of some particle, and it equals e to the 6t comma e to the t minus 1. Can you find the speed at the point 1, 0? Find the speed at the point 1, 0. Okay? Speed is what? Magnitude velocity vector. So now I'm just going to find step 1. I need v of t. What's v of t? R prime of t. Which is? What's that derivative? 6e to the 6t. Good job at chain rule. Good job at chain rule. 6e to the 6t. What's your v t minus 1? You know, am I done? Wait, you got to find the speed at that point. You got to find the speed at that point.
So 6.
So here it is again. Oh, and the mystery. That's not t. That's not t. This is x. This is y. What the heck is the t value again? This will be a common theme. Set this equal to the original what? Position? E to a 6t equals 1. What's the t value?
0.
E to the 0 is 1. So does everyone agree?
Mm-hmm.
I'll write it really big. I need to plug in t equals 0. Do you see what I mean? That's not given to you in the problem. That's where you can get a little bit lost in Calc3. Don't ever let it happen. You'll find Calc3 nice, just smooth ride. Just be careful in there. I got this parameter. They don't give it to me. They give me x and y. I just set it to the original. So we're going to get r prime of 0 then, huh? What's r prime of 0? I mean, that'd be the tangent vector. Does everyone agree?
Yeah.
This would be the tangent vector at t equals 0. 6 times e to 0 is 6. E to a 0 is what?
1.
One more thing. What's the speed at that point? Speed is
6 square plus 1 square square root.
the magnitude of r prime of 0. Or you can write speed is the magnitude of v of 0, right? If you want to use v as velocity vector. R prime. Square it up.
6 square plus 1 square.
How fast? Just didn't have units, so we'll just put square root of 36.
37.
Oh yeah, 37. Cool. Can we do another one of these? This only had what, x and y components? Let's do one with an x, y, z component. It goes fast. Again, be careful when they don't give you the what? This t value. Sometimes they do though. Sometimes they just, hey, find the speed at t equal to 5. You plug in a 5. Sometimes they give the point, and we gotta compare that. So when here's r of t this time, and they got e to the 6t It's got three components. Cosine of t, sine of 2t. Can you find the speed when t equals 0? Ah, this time they told you the t value. But can you find the speed of this particle when t equals 0? Well, again, we'll find r prime of t, and then we'll get r prime of 0. Then we'll take the magnitude of r prime of 0. Well, the reason I want to do another one, everyone, it just gives us extra practice with things like product rule, chain rule. What's the e to 6t?
1/6. Sorry, 6.
Well, what's the cosine of t?
Negative
Oh,
sign.
let me write it down again.
Negative.
S, C, S, C, S. Why do you know this? But just if it helps. Am I going that way or this way? I'm doing derivative. So what's the derivative of cosine? Negative sine of t. And what's this derivative?
2.
There you go. Cosine 2t times the chain 2. Now what do we got to plug in here? 6 times e to 0? What's sine of 0? 0. Cosine of 0? 1. So what's that magnitude? What's the speed?
Square root of 40.
Job. 2 squared is what? 4, and I get the square root of 40. Or if you want to simplify that radical, what's that? 2 square root of 10. Cool. Hey, try this. If you can do derivatives, can we do integrals? The only thing about integrals, just remember, we're going to have to use a plus constant, true? We're almost done with section 13U. We did the derivatives, but let's just practice a couple of these integrals. Okay. This is going to be very helpful for next week. Coming on Monday, when we see these like space curves, and we see like a ball being thrown in the air. We can try all this stuff. We can actually find the actual formula that represents that position at any moment of time. All right, v of t equals sine of t 4e to the 2t and 5t squared. This is velocity, or the tangent vector. The question is, can you find the position vector? And in fact, they gave us 1 point. They said the initial position, I'm going to go off to the side, I'll get this out of the way. The initial position for this problem, r of 0 equaled 1, 1, 1. This was given. This is the velocity vector. And they want you to find the position vector. This is the velocity vector. Can you find the position vector? What's going on here?
So integrate.
Position, velocity, acceleration. I'm going from velocity position. We have to do what?
Integrate.
Integrate. And then we'll use this to help us find those constants. Does that make sense?
Mm-hmm.
So don't forget to put your little plus constants in each one of these components. Well, let's try it. All right, r of t. Ready? What's the integral sign?
Negative cosine t
Plus the c. What's the integral of 4e2t? Good job, everyone. What he did was, he divided that 2, because it wasn't a derivative, it was an integral, which became a 2e to 2t. He actually did a use sub, if you think about it. Plus constant, and what's that integral?
5 over 3
5t cubed over 3 plus a.
c.
Okay, now these are all different constants, so if you want to distinguish between each constant, you can call that constant 1, constant 2, constant 3 because they all are just representing different constants. Right? How do I find these constants? Yeah, it's all about this. There it is. Hey, I didn't want to rush you on this. Was everyone okay with that one? That was not, I mean, that's the old, oh, I got to do the integral 4e to the 2t. 4e to the 2t, and that did involve a u sub, and we ended up just dividing a 2 from that rather than multiplying it from that. All right, so I'm going to write this. Negative cosine of 0 plus a c must be equal to the number 1. I'll just put a big wall just to separate this from this. Did everyone see what I did? This is to help me find the first constant. Negative cosine of that's a t value of 0, plus a constant must be equivalent to that number 1. Let me do it here. 2 times e to the 0 plus a constant must be equal to the number 1. And how about over here? 5/3 of 0 cubed plus a constant must be equal to the number 1 as well. Because this gave us the first components. What's this c, right? See, cosine of 0 is 1. What's this c? Whoops.
2.
C is 2. Okay, got it?
So that's e to the
2 plus c equals 1. Negative 1. And 0 plus c equals 1. C is just a what? 1. So I'm going to write the final answer right here. Here it is. R of t equals negative cosine t plus a 2, comma, 2e to the 2t plus a negative 1. And the last component is 5t cubed over 3 plus a 1. There's my answer. There's the answer. There's the vector curve. R of t is negative cosine t plus 2. 2e to the 2t plus negative 1, which I could change to just what? Minus 1. I'll do that. And then 5t cubed over 3 plus 1. Nice? Now I'm going to extend this. Can you find the position of this particle at t equal to 1? Can you find the position of this particle at t equal to 1? What would you do? So the question is, that was the position vector. You found it. But they said, now find the position vector of the position of this particle at a different t value than 0. And they said, find the position at 1. Now we just have to plug in a 1.
Well,
I just want to see, the answer may look funny because when the cosine of 1 radian is not neat, right? It's irrational, so I'm going to leave it as negative cosine of 1 plus 2, 2e to the 2 minus 1, and 5/3 plus 1. At least I could do that. What's 5/3 plus 3/3? 8/3? You know, great question. When they asked this, when they said find the, yeah, actually the question, I'll be clear, they said find just R of 1. So they just wanted to find this. The other one's that. We did integrals, we did speed, we did that. You know how to do a tangent vector, right? You know how to find that missing t, true? Cool. So this is the last thing we're going to do. This is the last problem. We're going to find the angle of intersection. So as I write this on the board, can you just think back to anything we've done that dealt with an angle?
yeah, the dot product, right?
Dot product.
Something we've had before, right? We're going to find the angle of intersection.
Dot product was cos with cos, right? Cosine.
That's right. Let me grab this proper one.
The cross product was sine. Right?
Don't worry, if I don't find a good problem out of here, I'll just make one up. 13/1 got it? Find the angle of intersection. 13/2. Here you go. This is on page 852. 13.2. This is number 33. Find the angle of intersection of these two vector curves. R sub 1 is t squared t cubed. R sub 2 is sine of t, sine of 2t, and t. Sine of t, sine of 2t, and t. Alright. So here's the two space curves. These are the two vector curves. And they want you to find the angle of intersection. So find the measure. Find the measure of the angle of intersection. Now, I'm hearing this word angle, right? We go back to this previous chapter, and you said there is a formula that involves angle. It was A dot B equals magnitude of A, magnitude of B times a cosine of A, right? We recall that. So what's theta equal to in this formula? It was cosine A dot B over magnitude of A, magnitude of B. Okay. So we got it. We just need to know what vectors are going to be A and B from these vector curves. I mean, these are just two vector curves that are what? Come like this, and we come up where they intersect, and we want to find the angle intersection. What kind of vectors should we use off these curves to find that angle? Because with the angle, we think what? Straight lines and stuff? So we need straight vectors. What kind of vectors? Tangent vectors. So for A and B, let's find the tangent vector to this curve, tangent vector to this curve, and we'll find the angle of intersection